To start off, let's talk about what space is. Space is where there is no air to breathe or to scatter light. But that's not all. It's also a vacuum, which means that sound cannot carry. Hypothetically, if you were floating around in space without a suit and tried screaming, no one could hear you, and you would die a painful death. Pretty cool, right? In this vast space, no pun intended, you could theoretically find stars, nebulas, black holes, and maybe even giant floating donuts. But today, we're going to explore neutron stars. Neutron stars are born from the intense explosion of a giant star. As a giant star ages, it begins to turn red, and hence the name red supergiant is given. The supergiant goes through a supernova, which blows the outer layer of the star into space. The object left behind is the core, which is the neutron star. The pressure of gravity upon the star causes it to collapse its material into itself. It does so with enough pressure to combine protons and electrons into neutrons. Because of the neutron star's immense density, one single teaspoon would weigh 1 billion tons. When the stars compress and shrink during a supernova, the result is a neutron star spinning at a high revolution. Neutron stars are commonly categorized into pulsars and magnetars. Pulsars are rapidly rotating neutron stars that give off pulses of radio waves, such as a light beam of a lighthouse. Scientists have noticed that the flickering of pulsars are very predictable and can be used for spaceflight navigation. In June 2017, a NASA mission was initiated with the purpose of attaching the Neutron Star Interior Composition Explorer, aka NICER, onto the International Space System. The NICER would be able to see X-ray emission from hotspots of neutron stars, collect information on critical mass and radius, and ultimately record arrival times of pulses from neutron stars. By using the arrival time, scientists could theoretically create a GPS system for the galaxy. This is just a theory, and will be a while until it is maybe achieved. In many cases, pulsar stars will orbit around one another. This is called a binary system. A binary system is when two stars orbit a common center of mass. The brighter star is the primary star, while the dimmer star is the secondary star. To organize systems, scientists will classify them. They can be classified by their orbits in categories wide and close. Wide binaries are stars that have orbits that keep them apart from each other, and closed binaries are when the orbits are close enough for mass to be transferred from one to another. Binary systems can also be classified by how they are observed. One classification in this category is an astrometric binary. These stars have a companion that aren't completely known. The companion has to be inferred. This could be because of the companion being too dim or hidden by the primary star. The galaxy is thought to contain about 100,000 pulsars. Yet, scientists have only identified fewer than 1,000. But an event that scientists did discover is when two stars are close enough to spiral inwards and create a huge explosion. This is called a kilonova. Scientists have also found evidence that this explosion is the source of most of the universe's gold, platinum, and other heavy elements. The other type of neutron star is the magnetar. They are believed to have the strongest magnetic field in the universe and are powerful enough to distort the shapes of atoms. But because the magnetic field is so strong, the star rotates slower. The dense stars can also have bursts of high-intensity radiation, which are caused by starquakes. They're practically earthquakes, but on a star. Pretty simple, right? The radiation released could be detected from Earth tens of thousands light years away. But obviously, the effect would be very weak and would just tickle the Earth. And that concludes neutron stars. I hope you enjoyed this video because this took long as